Alright, here's the lesson for you on trig functions for any angle. So this is starting like the no calculator parts of trigonometry. So let theta be an angle in standard form. It's like way back to our first lesson. And let x, y, that P, be a point on a terminal side of that angle theta. The distance from P to the origin, R, can be used using a formula. So you can even think of R like a radius. So if you think of a circle that goes all the way around, what would the radius be? And how do you find the radius? So the radius, or R, is the square root of x squared plus y squared. And that does come from the Pythagorean theorem. So using that idea, and the SOHCAHTOA idea, can we do different definitions for sine, cosine, tangent, and so on? So let's try. So let's use this right triangle here, the one on the left here. Remember, it's still SOHCAHTOA. So here we go. Sine is opposite over hypotenuse. Now in this case, the opposite side is y, and the adjacent side is x. So the x coordinate and the y coordinate. So for y, it's y over r. That's opposite over hypotenuse. Cosine, adjacent over hypotenuse. That's x over r. Tangent is opposite over adjacent. So using a point on that, it's y over x, opposite over adjacent. And then the reciprocals that come from that. All right, let's put this into practice. So you have a point 9, negative 12 on a point on the terminal side in standard form. Find the exact values of the trig functions for theta. So step 1 is to find r, and that's found by 9 squared plus negative 12 squared. Order doesn't matter. That's the square root of 81 and 144, or the square root of 225, which is 15. So step 1 is to find r. And then we're going to use the formulas that we have above. So we need to understand the opposite side is the y coordinate, and we said the y coordinate is negative 12. The adjacent is the x coordinate, and that's 9. And then instead of the hypotenuse, we have the radius, and we said that's equal to 15. So these are the numbers we're going to use. And we're still going to have this idea of SOHCAHTOA, but now we're going to understand it as a point on a circle. So sine theta is opposite over hypotenuse. So opposite's the y coordinate over the radius, which is 15. Don't reduce it down. And then the reciprocal. Cosine is adjacent over hypotenuse. Adjacent's the x coordinate, so it's 9 over 15, and then the reciprocal. And then tangent is opposite over adjacent, so that's negative 12 over 9, and then the reciprocal. Done. Let's try it again. So you have a point, negative 6, negative 2. So step 1 is to find the radius. So that's negative 6 squared plus negative 2 squared. So that's 36 and 4. So that's the square root of 40. And I am going to simplify that down to make it easier. So that's 4 times 10, so it's 2 root 10. And that's the radius. The x coordinate is negative 6, and the y coordinate is negative 2. And remind yourself, this means opposite, and this means adjacent. And this up here meant hypotenuse. So if you need to write SOHCAHTOA, do. But sine is opposite over hypotenuse. In this case, we're going to tell ourselves a different definition. So the y coordinate over the radius. We do need to write that better. So to write that better, the 2's do divide out and multiply top and bottom by root 10. So it's negative root 10 over 10. When I do the reciprocal, I'm going to go from the beginning here and go it's negative root 10 over 1, or just negative root 10. Cosine's the x coordinate over the radius. And again, I'm going to simplify it. So 2 goes into 6, 3, and then multiply top and bottom by root 10. When I do the reciprocal, it's going to be negative, and it's root 10 over 3. Tangent's opposite over adjacent. In this case, it's y over x. You can reduce it down, and then you have 3, because it's simple to reduce down. All right, turn the page. All right, depending on location of the terminal side of the angle, these black boxes should just be y and x coordinates. They're just, I don't know, the graphic services didn't come through about the x and the y coordinate. All right, depending on location of the terminal side of the angle, trig functions can be positive or negative. Using your knowledge of trig function values, identify the functions that are positive in each quadrant. So, if we have this understanding of SOHCAHTOA, that we've changed it now. So instead of writing down SOHCAHTOA, now we now know that sine is y over x, that cosine, sorry, y over x, y over the radius, x over the radius, and then y over x. Having that understanding of a point in terms of this, we can understand which ones are positive and negative. Know that the radius is always positive. So, tell me in quadrant 1, is the x and y coordinate positive for both of it? So, it's positive, it's positive, it's positive. All trig functions are positive in quadrant 1. In quadrant 2, just to remind you of the quadrants, in quadrant 2, x is negative and y is positive. So if x is negative, then which one is positive in quadrant number 2? So not cosine or its reciprocal, so sine is positive. And what else is positive is its reciprocal, cosecant. But tangent is not, because when you go positive divided by negative, it's a negative answer. So the only two that are positive in quadrant 2 is sine and cosecant. Quadrant 3. Well, in quadrant 3, x and y are both negative. That means sine is negative and cosine is negative. But tangent, when you go y divided by x, a negative divided by negative makes tangent positive, and its reciprocal partner would also be positive. And then the last quadrant. So in quadrant 4, x is positive and y is negative. So if x is positive, cosine is positive, and its reciprocal, secant, but the others will be negative. So the y coordinate's negative, which also makes tangent a negative answer. So the only two that are positive in quadrant 4 are cosine and secant. All right, let's see if we can test that out. If cosine is greater than 0, which quadrants could the angle be in? Well, if it's greater than 0, that's a way to say it's positive. And so it could be positive in quadrant 1, and it could also be positive in quadrant 4. Tangent is negative. Which quadrants could tangent be negative in? So now we're flipping it around. Not quadrant 1, so in quadrant 2 it's negative, not 3, and also in quadrant 4 it's negative. So tangent's negative in those two quadrants. If secant is negative, what quadrants could it be? So again, we're talking less than 0, negative. So not quadrant 1, they're all positive. Quadrant 2, yes, it's negative. Not and quadrant number 3, but not 4, because in 4 it's positive. So it's 2 and 3 where it's negative. If sine is negative and cotangent is positive, what quadrant could it be in? So let's do a set of ordered pairs for this. Sine goes with the y coordinate. So if the y coordinate is negative, we're going to put that in. Now, if cotangent is positive, this must also be negative, because the definition of cotangent is to divide these, and a negative divided by a negative is positive. So in quadrant number 3, cotangent's positive, but sine is negative. All right, use the information given to find the exact values of the 5 remaining trig functions of it. So we're going to draw this to the best of our ability, and then we're going to find what we need to find and fill this in. So we know that sine theta is 8 over 17. So it means it's positive, but tangent is negative. So what quadrant are we in if sine is positive? So I'll put that here. That means the y coordinate. And that tangent is negative. Well, if the y coordinate's positive, and when you go y over x, divide, the answer is negative, this must be negative. So the y coordinate's positive, so it works with sine, but when you divide it, the answer is negative. What quadrant are we in? So we're in quadrant number 2. So what I want you to do is I want you to draw a set of axes. Doesn't have to be big. And in quadrant number 2, you're going to draw a right triangle. Now this point here, that vertex of that, would be using these numbers. Now the definition of sine, so we can remember, again, is the y-coordinate divided by the radius. So the radius is 17, and the y-coordinate is 8, so that we can label it. Now what don't I know that I need to find here? Well, I need to find the x-coordinate. So it's the square root of 7 squared minus 8 squared. So if we do that work, 17 times 17, 8 times 8 subtract, it's 225, and the square root of 225, that's 15. It's a Pythagorean triplet. So now that I know all three sides, I then can fill this out. Now be careful here, because the x-coordinate in quadrant 2, the x value here is actually negative 15 in this quadrant. So find the value of that angle, and you have the answers. So cosine is x over r. Tangent is y over x. Cosecant is the reciprocal of sine. Secant's the reciprocal of cosine. Cotangent's the reciprocal of tangent. All right, let's try it again. So let's start with the quadrant. I know that's the tricky part. So cotangent is negative, and secant is greater than 0. So to figure out the quadrant, we're not going to start with tangent or cotangent, because that involves both the x and the y. But secant only involves the x. It's the reciprocal there. So the x-coordinate is positive. It goes with cosine. So cotangent's negative. So this other sign must be negative, so when you divide it, the answer is negative. So what quadrant are we in here? We're in quadrant number 4. So we're going to draw a right triangle in quadrant number 4. So that's this quadrant down here. And we're going to label it. Cotangent, by definition, is the reciprocal of tangent. So that's x over y. So that means the x-coordinate is, you got to be careful here. So when you see negative 4, that could be negative 4 over 1, or it could be positive 4 over negative 1. Either one it could be, but what fits for us? So for the x-coordinate, it fits that the x-coordinate is positive and the y-coordinate is negative. So be careful which one's positive and which one's negative when you have that. So it's positive 4 and negative 1. Find the radius. So it's the square root of 4 squared and negative 1 squared. And then use that value to find these. So sine again is y over r, and then multiplied by root 17, top and bottom. Cosine is x over r, multiply top and bottom by root 17. Tangent's y over x, so that's negative 1 over 4, the reciprocal of cotangent. Cosecant, the reciprocal of sine, so it's negative root 17 over 1, or just negative root 17. And secant's the reciprocal of cosine, which is root 17 over 4. All right, let's practice again. I need to know what quadrant it's in. So I need to know, does cosecant go with the x-coordinate or the y-coordinate? So cosecant's the reciprocal of sine, and sine goes with the y-coordinate. So I know the y-coordinate's negative. It says cosine is negative, so already I know x is also a negative sign. So the quadrant we're in here is quadrant number 3. So we're going to draw a right triangle in quadrant number 3. Notice when I do that, when I draw the right triangle, I draw the x, then the y, and then I make the triangle. Do not make the triangle different than that, where you're going along the y-axis. That's no. So along the x, then up or down, and then make your triangle. So this point right here, we're going to use the definition. Now, cosecant's the reciprocal of sine. So it's instead of y over r, it's r over y. So that means the radius is always positive. So root 5 is the radius, positive, and the y value is negative 2. So we still need to find the x value. So to find the x, it's the square root of root 5 squared minus root 2 squared. So when you have a hypotenuse and a leg, you subtract in that formula. So that's 5 take away 4. So the square root of 1 is just 1. Now make sure you recognize it's going to be negative 1 there because we're in the third quadrant. X is negative and y is negative. Now the definition. So sine is y over the radius, and then the reciprocal, or the, make that, rationalize the denominator, so multiply by root 5 top and bottom. Cosine, the x over r, again multiplied by root 5 top and bottom. Tangent, opposite over adjacent, or y over x, and it's going to be a positive answer because a negative divided by negative is positive. And then secant, that's the reciprocal of cosine, so it's negative root 5 over 1, or just negative root 5. And then cotangent is the reciprocal of 2, which is positive 1/2. So again, a negative divided by negative. So the only two positive answers are tangent and cotangent. All right, turn the page. Next part of the lesson, understanding the concept of what a reference angle is. So a reference angle is always acute, and a reference angle is always made with a horizontal. So when you draw an angle, whatever, if that angle is acute, then that angle is a reference angle. If that angle is obtuse, then you have to subtract 180, and it's the other side that is the reference angle. So for an angle in standard form, the reference angle is the positive acute angle made with the x-axis. And it's formed by the terminal side and the x. So sketch each angle, then find the reference angle. So if I was going to sketch 150, I don't need a protractor. I'm just going to label this. So 0, 90, 180, 270, 360. So there's my compass. 150 is obviously in quadrant number 2, and it's a little closer to 180. So I'm going to draw it in quadrant number 2, and that would be the angle if I was drawing 150. But the reference angle is not the obtuse angle. It's this angle made with the x-axis. It's on the other side. So obviously to find it, I would go 180 subtract, and the reference angle for that would be 30 degrees. 315. 315 is in the middle of quadrant number 4, and you would measure like that for 315. But I want the positive acute angle that's made this terminal side with the x-axis. So I'm actually looking for this little angle. So to do that, I would go 360 take away 315, and the angle there would be 45 degrees. So what we're learning is you're either going to go 180 or 360, and you're going to subtract to find the reference angle. If the angle is bigger than that, then you'd have to subtract to find the coterminal angle, and then do that. All right, for number 3, negative 240. So let's remind ourselves about negative angles that go clockwise. And there's the compass clockwise. Negative 240 is in quadrant number 2. And I'm not even going to draw negative 240. This is the angle I'm looking at. So draw the angle negative 240, but then just find the angle that side makes with the x-axis. So what is that angle? So negative 240, negative 180, let's subtract it. What angle is that in there between 240 and 180? So between 240 and 180, subtract, and you get 60. What happens when it's in radians? What we're going to have to do. So 5 pi over 3. It's going to be a little more challenging. So for 5 pi over 3, it's probably wise to convert it first. So 5 pi over 3 times 180 over pi. So I know the pi's divide out, 3 goes in 180, 60, so it's 60 times 5. It's 300. So that's the same as 300 degrees. So here's 300 degrees in quadrant number 4. And this is the angle I'm looking for. So again, this is 360. So what angle is that with the x-axis? So 360, take away 300, and you get the reference angle 60. 7 pi over 6. Convert it. So times 180 over pi. Again, the pi's divide out. 6 goes into 180, 30. So 7 times 30. So the angle is 210. So that's in quadrant number 3, 210. And again, we're looking for this angle there, made with the x-axis. So 210 take away 180. So what's that angle there made with the x-axis? 30 degrees. One more time. I need to convert this times 180 over pi. So 4 goes into 180 45 times, and the pi's divide out, so it's negative 225. So negative 225 is in the middle of quadrant number 2. And then what's that reference angle with the x-axis? So 225 and 180, when you subtract those, you get 45 degrees. And it's always written as a positive number. All right, use reference angles and the trig function values for angles in special right triangles to find each trig value. So without a calculator, what's the value of sine at 120? So step one is to find the reference angle. So without drawing it, I know if I go 180 take away 120, the reference angle is 60. The reference angle will give you the same answer with a smaller number. Next, what I'm going to do is I'm going to draw a right triangle that's 30, 60, 90, a special right triangle. So here's my 30, 60, 90, 30, 60, 90. I recall that opposite of 30 is 1, the hypotenuse is 2, and opposite of 60 is root 3. There's my special right triangle where I know the angles and the ratio of the sides. So in this one, SOHCAHTOA, at 60 degrees, what's opposite over hypotenuse? And the answer is root 3 over 2. Number 8, 225. So step one is to find the reference angle. So I'm going to use 180. It's always a positive answer. So 225 take away 180 to give me the positive answer, 45 degrees. So I know the reference angle is 45 degrees. I should also say this, that we also have to understand what we did before, whether the answer is positive or negative and what quadrant we're in. So I should go back to number 7 and say 120 is in quadrant number 2, and sine in quadrant number 2 is positive. That's why the answer is positive. So I should really write here, the answer for secant and 225, we're in quadrant number 3. And in quadrant number 3, the x-coordinate's negative, the reciprocal of that's negative. This is going to be a negative answer. So whatever answer I come up with, it's going to be negative, and it's the secant of 45 degrees. But I know the answer is negative because we're in quadrant number 3. So to get the answer, we're going to draw a 45, 45, 90 triangle. So 45, 45, 90. The ratio of the sides is 1, 1. It's isosceles. And the hypotenuse is root 2. So I know the answer is negative. The definition of secant is the reciprocal of cosine. So it's hypotenuse over adjacent. So pick either one, whichever one you want. It'll be root 2 over 1 or just root 2. And I know it's negative root 2 because we're in quadrant number 3. Number 9. Tangent of 11 pi over 6. So I'm going to convert it times 180 over pi. So the pi's cross out, 30, so 30 times 11, or 3 times 11, it's 330. So to find the reference angle, we're either going to use 360 or 180, whichever one's closer to 330. That would be 360, subtract, and the reference angle is 30 degrees. So I know I'm going to draw 30, 60, 90. So 30, 60, 90, 1, 2, root 3. So I know that's the special right triangle. What quadrant are we in? For 330 degrees. So we're in quadrant number 4, and is tangent positive or negative in quadrant number 4? So that's going back to the other sheet. So recognize the answer for tangent in quadrant 4 is negative. So it's going to be negative and the tangent of 30 degrees. So I know the answer is negative. I'm going to use this triangle. Now SOHCAHTOA, opposite. So here's 30. Opposite over adjacent. So that's negative 1 over root 3. And to rationalize it would be negative root 3 over 3. All right, number 10. No calculator. Negative 2 pi over 3. So negative 2 pi over 3, I will convert. So the pi's divide out. 3 goes into 180, 60. So it's negative 120. So the reference angle is negative 180 or 180. So when I subtract 180 and 120, I know the reference angle is 60. So we have a 60-degree reference angle when I subtract it to find it. Now what quadrant are we in? So for negative 120, we're in quadrant number 3. So if you think of a negative angle being drawn clockwise, negative 120 is in quadrant 3, which means our answer for cosecant is going to be negative because sine is negative and the reciprocal is negative. The only two that are positive in quadrant 3 are tangent and cotangent. So the answer is negative, and then I need to know the cosecant of 60 degrees. Now, to do that, I'm going to draw a right triangle. I'll just draw it right in here. So 30, 60, 90. So that's 1, 2 root 3. From 60, cosecant's the reciprocal, so it's hypotenuse over opposite. So I know the answer is negative. The hypotenuse is 2, and the opposite side of 60 is root 3. So if I rationalize it, it's negative 2 root 3 over 3. That takes some work, doesn't it, to get there without a calculator? If you just type that in your calculator, you would get the answer by pressing enter. But without a calculator, you have some thinking and work to do to get there. All right, when the terminal side of an angle is in standard position, lies on the x or the y-axis, the angle is called a quadrantal. Quadrantal angle? Right, first time. Look at that. It's an angle on an axis. And because it's on an axis, the angle doesn't make, it makes an angle of 90 degrees. And so we don't use SOHCAHTOA to understand the value of it. So at 0 degrees, at 90, at 180, and at 270, we have to understand they make a point on the axes. So here. So for this one, understand that the point here at 0 would be 0 and 1. 1 and 0. Silly me. This is 0 and 1. This is negative 1 and 0. And down here would be 0 and negative 1. So understanding our trig values, not SOHCAHTOA, but using the x and y coordinate to find the trig values, these are the x and y coordinates we would use. But anyways, you know 0, 90, 180, and 270. Now we get to learn about the unit circle. All right. You know what? I'm actually going to save the unit circle for another day. So that's going to be another video. So right now, Mr. GMath, over and out. I want you to go to your homework and practice what we just did. And if it's a question to do with the unit circle, then skip it for now, and we're going to come back to it later.